All right, so the last video was getting a little long, so I wanted to wrap it up by doing a second part here. So we're going to be graphing square root equations now, okay? So here we have y equals the square root of x plus 7. Okay, now one thing that I don't love about what Alex does here is they tell you how to find the leftmost point um, on a square root equation. They tell you to find three additional points, and that's fine. And for all of the problems they're going to give you, that's going to work. The problem is you don't always have a leftmost point, and I want to demonstrate that here in just a minute. Okay, so for the purpose of that particular homework assignment, they may tell you that might work for everything they're doing there, but I just wanted to show you in a last example that that's not always going to be the case. Okay, so I actually want to do this middle one here first. Okay, and then we'll graph the other two. We're going to do this a little out of order here. Okay, so we're going to do y is equal to the absolute value of x minus 1. Okay, now first of all, we need to understand our domain here. So we know that only values that make everything under the square root greater than or equal to 0 are going to make sense. Okay, so we need to go ahead and set this equal to, or set this everything on the inside greater than or equal to 0. So we can add 1 to both sides, and we'll get x is greater than or equal to 1. Okay, so what that means is, so now what we know is that the most extreme left or right point is going to be the point 1, 0. Okay, so as we don't have any additional values to deal with in terms of adding or subtracting here, but we do know that that's going to be roughly what that looks like. Okay, so at the point 1, 0, that's going to be our most extreme point. Well, if we plot points, you'll see where I'm going with this. But so let's go ahead and plot. Okay, so the next thing you need to consider when doing this is you need to make sure, again, everything under the square root sign stays greater than or equal to 0. So therefore, we're only going to consider values that are greater than or equal to 1. Okay? And to show where we got that 0, sorry, my brain fogged up for a second there. To show where we get that 0, if we plugged in y is equal to the square root of 1 minus 1, we plug in this x equals 1, we get y equals the square root of 0, which is just 0. So this is where we get our most extreme point from. Okay? So, like I said, we're only considering points now that are greater than or equal to 1. So let's plug in the point 2. So we'll have y equals the square root of 2 minus 1. Okay? Or we have square root of 1, or just 1. So for x equals 2, we'll have 2, 1. And I'm actually going to do 4 next because that's going to be a clean example. Let's consider y equals the square root of 4 minus 1. Okay. Actually, we're going to do 5 because we want to get the square root of 4. Let's consider y equals the square root of 5 minus 1. This is equal to the square root of 4, which is equal to 2. So if we go over to 5, okay, we're going to go up 2. So right here is the basic shape for our square root function, okay? And all of the examples that you're going to see in Alex are going to be going off to the right, and so you're going to have your leftmost point. But let's see what happens when that's not the case. Okay, so here we have y equals the square root of negative x minus 2. Okay, so let's go ahead and set everything underneath there greater than or equal to 0. So we'll have negative x minus 2 is greater than or equal to 0. So we can add 2 to both sides. And we'll get negative x is greater than or equal to 2. We can divide both sides by negative 1. And then that's going to give us x is less than or equal to negative 2. Okay? And the reason we flip that is because we had to divide by a negative 1. All right, so now let's go ahead and So really sorry, just to pause. What this means is we're only considering values that are less than or equal to -2. Okay, so if we plug in now x equals -2, we'll get -2 minus 2. That's going to give us the square root of 2 minus 2, or just 0. So we know that our most extreme point is going to be -2, 0. So we'll be right here. Okay? So now let's go ahead and plug in. Remember, we're only considering points to the left of -2. So let's plug in -3. So we'll have y equals the square root of -3 minus 2. Or we get the square root of 3 minus 2, or the square root of 1, which is just 1. So at -3, we get 1. It's going to look like that. So now you're going to notice we're going to the left. So in this situation, it's going to be our rightmost point. What if we tried maybe y equals, x equals -6? Let's try that. -6 minus 2, or we get square root of 6 minus 2, which is the square root of 4, or just 2. So for -6, we'll get 2. So this is the basic shape for our graph here. All right, so now let's take a look at this first one. Let's say we have y equals the square root of x plus 7. Remember, everything under the square root sign has to be greater than or equal to 0. So we have, let's go ahead and do that. Let's set this x greater than or equal to 0. Okay, so if we plug in 0, we'll get y equals square root of 0 plus 7, or we'll just end up with 7. Okay, so at the point 0, 7, that's going to be our most extreme point. So we're going to go actually up 7, 2, 4, 6, 7. Here we go. And so they don't always necessarily have to start at y equals 0. All right, so, but we want everything to be greater than or equal to 0. So let's plug in x equals 1. Y equals the square root of 1 plus 7, or that's just 1 plus 7, or 8. So if we go over to 1, we'll go up to 8. If we try 4, y equals the square root of 4 plus 7, we'll get 2 plus 7, which is 9. So if we go over to 4, we're going to go up to 9. So this is going to be the basic shape for this graph. So hopefully that it helps you better understand how square root functions and equations work, or at least how they look on paper.